In this lesson on classroom mathematics, we are looking at chapter 14 and it's on the Theorem of Pythagoras. So just an overview of the video, we're going to look at the terminology, then we're going to look at determining whether a triangle is a right angle triangle, and then we're going to use the Theorem of Pythagoras in problems. So first of all, defining the Theorem of Pythagoras, in any right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. So what this basically means is that the hypotenuse, which is this side, which is always the longest side, which is opposite the right angle, the square of that is equal to the other two sides added together. So we can put this into a formula that looks as follows. We can say that AB squared is equal to BC squared plus AC squared. Or we can also write it as C squared equals to A squared plus B squared. Right, so for the first example, we have the following triangle. It's a right angle triangle. And what we need to find is we need to find PA. So to find PA, we can substitute in, or we can write PA squared is equal to WP squared plus WA squared. Alright, so and then our reason is Pythagoras, because that's the theorem that we've used. And then we can substitute in our known values. So PA squared is equal to, now WP is 11 squared plus 60 millimeters squared. So PA should then be the square root of 11 squared plus 60 squared, and then we can put that onto the calculator and find the value for PA. So PA is equal to the square root of 11 squared plus 60 squared, and that is equal to 61 millimeters. Now for example 2, we need to find the short side. So if we write down the formula, we know that the long side, xy squared, is equal to the two short sides added squared. So that's yz squared plus xz squared. And our reason is Pythagoras. Alright, so now we want to find this side. So in order to find that side, we need to take the other short side over to the other side. This will leave us with xy squared equals to, minus the other short side, xz squared equal to yz squared. Alright, so this is the long way. We state our theorem and then we solve for the one we want to find. But in practice, you can always know if you want to find a short side, you can say the short side, in our case yz squared, is always equal to the long side minus the other short side. So it's going to be xy squared minus the other short side, which is xz squared. And then of course, if you want to find the long side, it's just the other two added together. So let's substitute in our values. We have 17 squared minus 15 squared, and then yz is equal to the square root of 17 squared minus 15 squared. And if we put that on the calculator, we get 17 squared minus 15 squared, and that gives us 8. And we are working with centimeters, so that's 8 centimeters. For example 3, we once again have a short side to solve for, but remember, like we did in the previous one, to save time, we can say if we want to find the short side, keep QP squared, we're going to take the long side, the hypotenuse, QR squared, and subtract the other short side, PR squared. And our reason, Pythagoras. Alright, so substituting in our values. So QP squared is equal to, alright, and also we are given that it is QP P, and we need to find R. So they have done it in terms of, let's just do that as well, to find R. So this is R over here. So R squared is equal to this small p squared, 37 squared, minus this PR squared, or in other words Q squared, which is 12. So then if we solve for R, we get the square root of 37 squared minus 12 squared. And then we type that into the calculator. So we have 37 squared minus 12 squared is equal to 35. So 35, and we are working with centimeters. Now for example 4, we need to find AC, and that's the hypotenuse side. And we're given that this is C is 2, A is 1, and we need to find B. Right, so if I write that down, B squared is equal to A squared plus C squared. And reason is Pythagoras. And then I substitute in my values. So B squared is equal to A is 1 squared plus C is 2. So that's squared. So B is then equal to the square root of 1 squared plus 2 squared. And this then is going to be equal to square root of 1 squared plus 2 squared. And this gives us the square root of 5. But the question says we need to write it down to correct to 2 decimal places. So we just press SD over here. And then we get 2.24. So 2.24. And that is in meters. Right, so that was the basic terminology and examples. Let's now look at determining whether a triangle is a right-angled triangle. So this is if the sum of the square of two sides of a triangle is equal to the square of the longest side, then the triangle is right-angled. So in this case, we are just basically working with the converse of the theorem. So what it says is, if we are not given that it's a right-angled triangle, but we know that this long side squared is equal to the two short sides squared added together, then we know that the triangle should be right-angled. So let's look at the first example. Determine whether triangle PQR with P equal to 10 centimeters, Q equal to 6, and R equal to 8 is a right-angled triangle. If so, which angle is the right angle? Now, first of all, we look for the longest side, because the longest side is always the hypotenuse side, which is right across or opposite the right angle. So to just get a clear picture of this, we just draw the triangle with our longest side as the hypotenuse side. So if this is a right angle triangle, then this P would be the right angle. Now, first thing I'm going to do is I'm going to write down the first statement. We need to prove that R squared plus Q squared is equal to P squared. So first we're going to substitute, or we're going to solve R squared plus Q squared and see what that gives us. So this is then 8 squared plus 6 squared, and that gives us, if we type that into the calculator, that gives us 8 squared plus 6 squared. It gives us 100. Right, and then if I have P squared is equal to 10 squared, which is equal to 100. Now, since P squared is equal to R squared plus Q squared, we can say, therefore, triangle PQR will be a right angle triangle. PQR is a right angled triangle. Example 2, determine whether triangle XYZ is with XZ equal to 3 and the square root of 2 millimeters, YZ is 3 millimeters and XY is 1 millimeter, is a right angle triangle. So if so, which angle is the right angle. So first of all, let's identify the longest side. The longest side is this xz. So drawing the graph, or drawing the triangle, we place 3 with square root of 2 as the hypotenuse. Alright, so now let's see, we need to show that zy, or we need to see whether zy squared plus xy squared, if that's equal to xz squared. So first we calculate zy squared plus xy squared. So that would be 3 squared plus 1 squared, and then calculating that, this is just 9 plus 1, so that's equal to 10. And then for xz squared, this is going to be 3 square root of 2 all squared. So this gives me 9 times 2, so this is 18. Now we can clearly see that they are not equal, so we just state that zy squared plus xy squared is not equal to xz squared, and therefore triangle xyz is not a right angled triangle. Now just a quick thing on Pythagorean triple. If the lengths of the sides of a right angled triangle are all natural numbers, we call the 3 numbers that represent the lengths of the sides of the triangle a Pythagorean triple. So that means that if I have c squared equals to a squared plus b squared, then these would satisfy this equation. So if I, for example, substitute in a 7 squared plus the 24 squared, then I'd get 25 squared. So this is just for interest. This is not really something that you need to know for exams, but it's just for interest sake. Okay, so that was how to determine whether an angle is right angled. So finally we go on to using the theorem of Pythagoras in problems. Now for the first example, it says calculate the length of DC. So DC is over here, and we can see that it forms part of a right angle triangle. But the only thing we know is we know that AD is 15. We do not know what AC is. So that's a problem. But we see that AC is in this triangle, which we do know the other 2 sides of, and it is also a right angle triangle. So therefore we can start with a smaller triangle. We can say, since this is the hypotenuse, we can say that AC squared is equal to AB squared plus BC squared. And then we have to state that we used Pythagoras, and we substitute in our value. So AC squared is equal to AB, which is 4 squared plus 3 squared, and AC is therefore the square root of 4 squared plus 3 squared, and that would give us the square root of 4 squared plus 3 squared is equal to 5. Okay, so now that we know this is 5, we can now move on to the bigger triangle, where we have CD squared is equal to AD squared plus AC squared. And once again, we state that we used Pythagoras, and we substitute in our values. CD squared is equal to AD, which is 15 squared plus 5 squared. So CD is the square root of 15 squared plus 5 squared, and that would give us the square root of 15 squared plus 5 squared would give us 5 square root of 10. So 5 square root of 10 units. Then for example 2, in the diagram below, triangle ABD is an isosceles triangle with AD being equal to BD. And then triangle BDC is a right angle triangle with angle C equal to 90 degrees. So DC is parallel to DC, and AB are parallel, and BD is equal to 13, CD is equal to 5 centimeters. Calculate the perimeter of the quadrilateral ABCD, and then calculate the area of the quadrilateral ABCD. Alright, so we need to find the perimeter. Now, before we can find the perimeter, there are a few sides that we don't know. So we can state that BD is equal to AD. That's a given. Right? Then we have this EB. So EB is also equal to 5. We know this is 13. Just say that's 13. Then EB is equal to 5, and that's just the opposite sides of a rectangle. You can say opposite sides of rectangle. Okay, then we know that AE is also 5. So AE is also 5. That is because the height of a isosceles triangle will bisect the base. Alright, and then the other side, the last side that we still need is BC. Now, in order to find BC, we're going to have to use Pythagoras. So BC squared is equal to, now remember BC here is one of the short sides, so we need to say the long side, which is BD squared minus DC squared. Right, and we have used Pythagoras. Then we just substitute in our value. So BC squared is equal to BD, which is 13 squared minus 5 squared. And then BC is equal to the square root of 13 squared minus 5 squared, and that is equal to 12. So if this is equal to 12, I can now say that the perimeter will be equal to, if I go right around, it's going to be equal to CB plus BA plus AD, and then finally plus DC, which is equal to 12 plus 10 plus 13 plus 5. Right, so this then is equal to 22. This is equal to 35 plus 5 is equal to 40 centimeters. Okay, and then for B, we need to find the area. So in our case, the area is equal to the area of triangle. So we've got this triangle and we've got this triangle. If we break this whole shape into two triangles, we've got triangle BDC plus the area of triangle ABD. And then the formula for the area of a triangle is half base times height. So for the first triangle, I've got half times my base, in this case is DC, and my height is going to be BC, perpendicular height is BC, and that's my first triangle, plus the other triangle, my base here is AB, so half times AB times my perpendicular height. Now in this case, our perpendicular height is also 12, because these are opposite sides of a rectangle, so DE, which is also 12, and now we simply substitute in our values. Half times DC, which is 5 times 12, and then plus half times AB, which is 10, times DE, which is 12. Okay, so this is then half times 12, so this works out to be 6 times 5, which is 30, plus this is equal to 60, and therefore the total surface, the area will then be 90 centimeters squared. Right, so that was using the theorem in problems, and that means you can now go ahead and do exercise 14.1.